sounds like all my.
Okay, guys. So today we're going to be sketching functions, but before we do that, I want to talk about domains and zeros. So when we discuss the domain of something, if I give you an algebraic expression for it, for the function, essentially it's going to be all real numbers unless there's something restricting it. There's three different things that can restrict your domain. The first thing that can restrict your domain, so we're going to say domain restrictions, is if you have a radical with a variable underneath of it. If you have a radical with a variable underneath of it, we know that I can't have a negative number underneath that radical. Why? Why can't we have a negative number underneath that radical? What does it make it? Okay. Imaginary. So we know that the radicand, whatever that radicand is, has to be greater than or equal to 0. Is it okay if it's 0? Is that fine? Absolutely. It's completely fine for x to be 0. Right. The second thing that will restrict your domain is if you have some expression where, let's say you have some number n in the numerator, but then you have a variable in the denominator. What number can the denominator never be? What's that number? 0. So we know in this scenario our domain's restricted because x cannot equal 0. Our denominator can never equal 0. And the third thing that will restrict our domain is if you have in the denominator not only a variable, but a variable and a radical. Because when we have a radical in the numerator, we know it has to be greater than or equal to 0 because it can't be imaginary. We can't let that radicand be negative because that will make it imaginary. But now that that radical's in the denominator, can it now equal 0? No. So the restriction for something that looks like this will be x has to be greater than 0. It cannot be equal to 0. The first one,
Why has to be greater than or equal to 0?
Because if we're less than 0, that brings us to negative numbers, right? And if we have a negative number underneath the radical, what does that make it? What kind of number? Imaginary. And we can't graph imaginary numbers, right? So this is restricting our domain.
But there it can be equal to 0?
Yeah, because 0 is a real number. That's perfectly fine. For x to equal 0, that's fine. But x can't equal I and us plot it. But can we plot x equals 0? Sure. Okay, so what I want us to do now is I want us to find the domain and zeros. All right, so if I want to identify the domain, remember, your domain is always all real numbers except if there's going to be a restriction. And there's 3 scenarios that create restrictions. Does this fit one of the 3 scenarios? Absolutely. We have a radical. Where is that radical? In the numerator or in the denominator? In the numerator. So can our numerator be 0? Is that okay? Absolutely. So we need to make sure that our radicand, our x plus 3, is greater than or equal to 0. Because if our radicand were less than 0, that's when we get to imaginary numbers. So when we solve this, we get x is greater than or equal to -3. Now there's a bunch of different ways you can write out this domain. The first way we're going to do is interval notation. We'll write set notation first. Set notation. And in set notation, we do our squiggly brackets. And we have x such that. Then you write your inequality, x is greater than or equal to -3, and you close your squiggly brackets. You could also elaborate this even more if you wanted to for set notation, x such that -3 is less than or equal to x, which is less than +infinity. Both of those are considered set notation. I do not care which way you write it. The other notation is interval notation. And for an interval notation, what you're going to do is you're going to pick the smallest number in this domain and see how its x is less than or equal to -3. So do we agree -3 is our smallest number? So we do -3, and because it's equal, it can be equal to -3, we're going to do a square bracket. And then our biggest number, where there is no biggest number, because it's saying as long as you're bigger than -3 or equal to -3, you're good. So that means we're going to infinity. Can we ever touch infinity? Can it be incorporated? No. So that's why it's always a parenthesis at infinity. Can't plot infinity. Yes.
On a test, do you do it either way, or will you tell us what to do?
You have to know both. I'll ask, for some, I'll let you do whatever you want, but for a couple, I'll say write this in set or write this in interval. All right, let's do another one. Oh, we didn't find the zeros. Now let's find, so we found our domain. So now when we want to find the zeros, ultimately when you're finding zeros, we're letting y equal 0. But a shortcut for these functions is just to set the numerator equal to 0. So here we have f of x is equal to the root of x plus 3. Do you guys all agree that f of x and y, they're interchangeable? F of x and y are interchangeable. So this is the same as saying y is equal to the square root of x plus 3. So we now have 0 is equal to the root of x plus 3. Now we need to solve for x. To solve for x, we need to get rid of that radical, so I'm going to square both sides. And we will have 0 is equal to x plus 3, subtract that 3, and we get x is equal to -3.
When you say that we set the numerator equal to 0, would that mean if there's a denominator on the right side of the equation, on this equation with x is?
It means that denominator wouldn't really matter. So if I had x plus 2 over 3, when will this equal 0? When the numerator equals 0, right? Because it's 0 over a number that gives us that 0. You see what I'm saying? All right, let's look at another one. Don't worry about the radical being in the denominator. We leave it. All I want to know is the domain and the zeros. Not asking for anything else. So for the domain, it's going to be restricted. How do I know it's going to be restricted? That it's not all real numbers. James? Yeah?
It's like in the denominator.
Good. There's a variable in the denominator. And not only is there a variable in the denominator, what else? It's a variable and a, Michael? Radical. So I had said when you have a variable and a radical in that denominator, we're going to take our radicand, which is the expression underneath the radical, and we know that has to be greater than 0. Can it be equal to 0? No, because if that denominator ends up being 0, then we're undefined. We don't have a defined expression, so we can't have that. So our domain is x is greater than -3. So we can write this in set notation. X such that x is greater than -3. Our interval notation is going to be -3, but notice how I did parentheses, not a square bracket. So -3 all the way to infinity. All right, now let's talk about our zeros. Zero or zeros. All right, so we have f of x is equal to 1 over the square root of x plus 3. And I had told you the real way of thinking of this is letting y equal 0. So f of x and y are interchangeable, so I'm going to say 0 is equal to 1 over the square root of x plus 3. We would have to solve for x, right? So I'm going to cross multiply. This is over 1. I'm going to cross multiply. But when I cross multiply, 0 times anything is what? 0. So this is saying 0 is equal to 1. Is that a true statement? 0 is equal to 1? No, this is not a true statement. We were not able to solve for x. So what does this tell you? No y-intercept. No x-intercept. Or no x-intercept. That's what the zeros are. Zeros are x-intercepts, so no x-intercept. So our graph is not crossing the x-axis at all. Okay, so now that we just sort of recapped about domain and zeros, what I want us to do now is just go through a few of our standard or parent graphs that you should have memorized. I'm going to say okay, so the first one that we're going to talk about is the parabola y equals x squared. The parent graph for this, the y equals x squared, is just a parabola with a turning point at the origin, and then I call it a smile. And now we can shift. So now these parent graphs can be shifted, and the shifting takes on the format of y equals a times the quantity of x minus h squared plus k. Okay, so now for the a, what we care about here, not so much the number, we care about if it's positive or negative. If it's positive, we open up, like the parabola is going to open up. If it's negative, the parabola will open down. The h is going to represent our horizontal shift. And k will represent our vertical shift. Now, this shifting only works, like this shortcut for the shifting, like the HK shifting, this only works is if the coefficient, only works if coefficient on x is 1. And for the purpose of this class, our coefficient will be 1, but I just need you to know that if I put like a 2x minus 3, that whole shortcut for this shifting won't work. All right, other thing before we move on to the next parent graph, the other thing I want to talk about is, see how this is an x minus h? So that means in this format we need the minus. So whatever it is, let's say it's like x minus 3, we shift 3 units to the right. In order for it to shift to the negative to the left, it would have to be a plus. So it's sort of the opposite of what your instincts tell you. So if it's a minus, we're moving in the positive direction. If it's a plus, we move in the negative direction. Do the same rules apply for k? No, because this is a plus k. So plus means up, minus k means down. All right, so that's our first parent graph. Our second parent graph, we're going to have y equals the root of x. And the parent graph looks like, I call it a shooting star. So your starting point is 0, 0, but then you go to the right and to the left. Now this can also be shifted. And what's great about all the parent graphs that we're talking about today, their shifts follow the same pattern, which is really good. So once you memorize it once, it's the same for all of them. So this is y equals a times the root of x minus h plus k. So for the a, all we care about is positive or negative. The positive is going to go up. The negative will be down. The h represents our horizontal shift. And the k will represent our vertical shift. And similar to the parabola, the shifting only works if the coefficient of x is 1. Okay, so now we did the parabola, we did the shooting star. Now the last parent function we need to memorize is the absolute value. Y equals the absolute value of x. This is a V shape at the turning point of the origin. And similar to the parabola and the shooting star, we will have the same exact shifting. So y will equal a times the absolute value of x minus h plus k. Does anybody want me to write it all over again, what all that shifting means? Or you got it by now? Okay, great. Are you sure?
Yeah.
Okay.
I'll just read them.
Okay, let's practice some problems now. Anybody still copying? Okay. So y equals the absolute value of x plus 3 minus 1. Okay, so in my head, I see the absolute value lines, and I think, okay, well, my parent graph is that V centered at 0, 0. At turning point 0, 0. Do we agree with that? So that's the first thing you want to realize. What does this graph look like? We know it looks like a V, and the parent graph, turning point is 0, 0. But now we are shifting this turning point. Where are we shifting this turning point? Well, according to our shifting rules, we have a times the absolute value of x minus h plus k. Do we all agree, since there's no number here for a, that it's a 1 and that it's positive? So we are opening up. So this a is up. Now remember, it's supposed to be x minus h, but it's an x plus 3. So am I shifting 3 units to the right or 3 units to the left? 3 left. So we're taking our turning point. We're going to go 3 units to the left and 1 unit where? Up or down? Down. So 3 to the left and 1 unit down. So let's get a sketch going. So now my parent graph, my point was 0, 0, my turning point. But now I'm going to shift that 3 units to the left, 1, 2, 3, and 1 unit down. Right, now I'm going to ask some more things for us to find. So we have our turning point. Now what I want us to find is the x-intercept. I can also call this zeros. They're the same thing. So I could say find the x-intercept or find the zeros. And the way we do this is we take our function and we let y equal 0. So we're going to say x plus 3 minus 1 equals 0. And then we solve for x. So I'm going to bring that one over. We're going to isolate those absolute value lines. And you guys should remember from Algebra 1 how to solve this. We're going to say x plus 3 equals 1 and x plus 3 equals negative 1. So x will equal negative 2 and x will equal negative 4. right, so now we plot. So x equals -2 and x equals -4. All right, I'm also going to ask for the y-intercept. All right, for the y-intercept, we're going to let x equal 0. So let's write this down, let x equal 0. So the absolute value of 0 plus 3 minus 1. So y equals the absolute value of 3 minus 1. So this is 2. So for the x-intercept, we let y equal 0. For the y-intercept, we let x equal 0. All right, so let's plot this. Y equals 2. And because the absolute value is symmetrical, just to make my graph look nicer, I'm going to get sort of the symmetry going, so I'll plot the other point that would correspond to that y-intercept on the other side. It's a little bit further because my things are not really aligned properly, but we get the gist. All right, let's do another one. Okay, so y equals a times the root of x minus h plus k. And I hope that you think in your head, okay, parent graph is a shooting star. Right, but we are absolutely shifting this graph. Somebody tell me, where are we shifting this graph? In what direction? Philip?
To the left.
To the left, exactly. Am I moving up or down at all? No. Are we opening, are we shooting up or are we shooting down? Up, because there's really a 1 in front of that, which is positive. So now let's get our sketch going. Oh, guys, I forgot to do the domain and range in the last problem. We'll go back. We'll go back to the last problem and do our domain and range. So now our start point for our parent graph is 0, 0. We're shifting 2 units to the left. So now that's my starting point. I am going to ask for the x-intercept, the y-intercept, the domain, and the range. And we'll go back to the other one and write out our domain and range also. Guys, without doing any algebraic work, do we know the x-intercept? We do, Danny.
Is it x and x-intercept, so y equals 0, right?
I'm sorry?
x-intercept is for y equals.
Yeah, so we can do it algebraically, absolutely, and you're going to get the right answer. But I'm saying as a time saver, right? Because we all know that sometimes we don't have that much time on a test. So instead of doing it algebraically, is there a way to know the x-intercept right now? Yeah, because we have our starting point at x equals -2. Am I ever, on a shooting star, am I ever going to cross that x-axis again? No, because it's just going to go up and right for the rest of it, right? So we know that x is equal to -2. Let's say you didn't think ahead, right? Let's say you didn't think of that. If you solved it algebraically, you'd get the same thing. So you get y equals the root of x plus 2. We're going to let y equal 0. We're going to square both sides. So we have 0 is equal to x plus 2. X is equal to -2. Same thing. All right, for the y-intercept, we cannot predict the y-intercept right now. We actually have to do some algebraic work. So we're going to take our y equals the root of x plus 2. We're going to plug in a 0 for x. So y equals the root of 0 plus 2. So y equals the root of 2. We have to estimate this radical in order to plot it. What do I mean when I say estimate the radical? The way we estimate the value of a radical is you're going to choose the two closest perfect squares to that radicand. One smaller, one bigger. So what is the closest perfect square to 2? Smaller is 1. Yep, so we take the square root of 1. What about bigger? Root 4. So what's the square root of 1? 1. What's the square root of 4? 2. That means 2 is going to be somewhere between 1 and 2. Do we agree 2 is sort of like the midpoint, right? So I'm going to estimate around 1.5. So we have 1, 2, 3, 1.5 is about here. And now we sketch. Okay, so now the domain. Yes?
Sorry, could you just explain again how you got the x-intercept to be -2 without calculating?
Oh, okay. So remember when we were talking about shifting? So we said the shooting star, the parent graph starts at 0, 0, and then goes to the right. But we shifted it 2 units to the left without moving it up or down at all. So that means I'm now starting at x equals -2, which is the x-intercept. And if you know the shooting star is not going to hit the x again, you know that could be the only x-intercept. Okay, so now the domain. You can solve the domain algebraically, or you now have a graph. You can go off of your graph. Remember, domain is left to right. So the furthest point left, what is it? -2. Am I ever stopping my movement to the right? No, so we're going from -2 all the way to infinity. So my domain is -2. Is -2 included? Yeah, so square bracket, -2 all the way to infinity. That's interval notation. If we're going to do set notation, it's x such that x is greater than or equal to -2. All right, yes?
Would it be fine if you wrote -2 is less than or equal to x, which is less
Yep.
than
Infinity, perfect. Yes.
Wait, well, we need to know like how to write both of these.
Yes, you need to know how to write both. And you need to know the names of both. So the top one I wrote was interval notation. The bottom one was set notation. I won't tell you which one is which. So if I say write this in interval notation, you have to know how to write it. Okay, the range. Range is bottom to top in our graph. So what's the lowest point of this graph? Not -2. 0. Is 0 included? Yes. Is there a top point, or is it just going to keep going up? Keeps going up. So we say infinity. if we're going to write set notation, y such that y is greater than or equal to 0. So other things I've seen, I will take points off. A lot of people, when I ask for the range, write x. If you write x when I ask you for the range, you're not going to get credit for that. Range is y, domain is x, based on our function. Okay, we're going to do one more and then call it a day. Oh wait, I didn't go back and talk about the other domain and range, did I? All right, let's talk about the absolute value domain. All right, absolute value domain, left to right. Any restrictions there at all? No, so we are infinities, negative infinity to positive infinity. That's our interval notation. Our set notation will be x such that negative infinity is less than x, which is less than infinity, or I'll accept all real numbers. I'll accept any one of those. Yes?
Why would it be
Infinity, because remember, domain is left, right? Furthest left is an arrow. Furthest right is an arrow. And remember, go back to our function. Were there any of those restrictions on our domain? There's no variable in the denominator. There's no radical. So we know there's no restrictions, which means it's going to be all real numbers. All right, and our range. Remember, range is bottom to top. What's my lowest point? -1. And our highest point is infinity. So that's interval notation. If we wrote set notation, it'd be y such that y is greater than or equal to 1. All right, the very last graph. Okay, so you tell me, what is this parent graph? A what? What is this parent graph? It's a parabola. This parent graph is a parabola. It's a smile. This parent graph is a parabola. So now let's talk about the shifting. So if we're going to shift, it's a times the quantity of x minus h squared plus k. So what does this negative in front tell us? We're opening up or opening down? Down. So this negative in front tells us we're frowning, it's not smiling, it's not happy. Now, I think we are all agreeing that there will be some shifting because of that +1. Now, you tell me, that +1, is that going to represent a horizontal shift, a vertical shift, or both? Okay, good. Vertical. Why vertical and not horizontal? You don't know? Next. Good, it's not in the parentheses. So remember, the horizontal shift has to be sort of within the quantity with the x, like quantified with the x. So now we are taking our turning point. Yes?
Why don't you put the x minus h in the square instead of like above between square?
Oh, this is the format for shifting. Like, so whatever is shifting left or right has to be in the parentheses with the x. If there's nothing in the parentheses with the x, that means it's not shifting left or right or at all. Okay, so now let's shift. So I'm taking that 0, 0 turning point and I'm moving 1 up. All right, so now I have to Same things I've been asking, x-intercept, y-intercept, domain, and range. So how do we find the x-intercept? Danny? Y equals 0. So we have y equals negative x squared plus 1. So 0 equals negative x squared plus 1. Negative 1 equals negative x squared. Divide by 1. 1 equals x squared. Root both sides. X equals plus or minus 1. So I have two x-intercepts this time. I have positive 1 and negative 1. I already know my y-intercept. How? Without doing any algebraic work. How do I already know my y-intercept? Danny? Because that is our turning point, right? That's our turning point. So we know y equals positive 1 is our y-intercept. So now we have everything we need to sketch our graph. So looking at this graph, what is our domain? Left and right. Philip? Good. Negative infinity to positive infinity. Or we could say all real numbers, or we can say x such that negative infinity is less than x, which is less than positive infinity. All the same thing. All right. And the last thing we're finding is the range. Who has the range for me? Tejas?
Like bracket 1 to negative infinity.
Close. You always do the smallest thing first. So negative infinity is less than 1. So you're going to say parenthesis negative infinity to 1 bracket. And then in set notation, we'd say y such that y is less than or equal to 1. All right, this is where we're going to stop. No homework.